Hi students! If you're watching this, then you've successfully found my video tutorial page on YouTube, so well done. I think this is going to be a very useful resource for you in terms of learning all of the different functions of Scratch programming. So in this series you're going to find a set of tutorials, and every tutorial is going to provide you a little bit of different information about how to use Scratch and the different tools that it has and the different types of projects that you can make. And I want you to use this to practice in your own time, because our Junior Tech ECA is only 1 hour per week, and this is not enough time for me to be able to explain difficult concepts to you and for you to be able to practice using a lot of the different functions in Scratch and also be able to make a very nice project by the end of the year. So, hopefully you will take what you've learned in your lessons with me, and you will go home and you will practice remaking what you made in the lesson, and you will also refer to these tutorials. Now, there are some tutorials on Scratch also built in if you would like to check these out, but I thought I would make you a series myself so that you can get used to me teaching you also. So, what I'm going to do, I'm going to use my webcam to show you my desktop, and I will walk through all of the different features in Scratch that you can use straight away. If you have any questions, then please do ask me at the beginning of your next lesson, or you can also email me at my Greesheets email address, which I'll provide you. Now, without further ado, let's get to it. So this first tutorial is going to be a recap of what we covered in lesson 1. So I'm just going to show you some of the basic functions and tools and just get you used to loading Scratch, making sure you know where everything is, and so you're comfortable using the software. And once you're comfortable using the software, we can move on to make some really cool stuff. I hope you enjoy. Please give me some feedback. Thank you. Okay, students, so the first thing that we need to do is to open an internet browser. Today I'm going to be using Google Chrome, and we need to navigate to the Scratch programming website. We're going to be doing all of our projects online so that you can save them as you go along and build up a portfolio. And then you can also share them with other people and collaborate, which is also always a very good thing for people learning programming. Working together to solve problems is a very useful skill in life and also fundamental to programming. The first thing we need to do is find the Scratch website. We could search in the toolbar for Google here and type Scratch, but I know the website is www.scratch.mit.edu. Now, this is the web address for the Scratch programming software, and the web address works exactly like your address at home. So your house has an address so that the postman can bring you your mail and people know where you live. And this address tells you where on the internet the Scratch program lives. The first screen that you will see is this one here, Welcome to Scratch. And as you can see here, we've got some basic tutorials, starter projects, ways of connecting with other people, and some featured projects made by the Scratch team as an example to show off what it can do. And we will get around to making some of these, and you can play around and make your own projects also, and this is going to be the theme for this term. But first today we'll click Create, but we're not going to create too much today. I'm just going to give you an idea of where everything is in the software. So we click Create, and this will load the project page. Every new project looks exactly the same. Here the software is creating the project, it's building everything that it needs. So, what do we have here? We've got 3 different screens. Over in the left here, we have all of our functions. This is the programming code for Scratch. All of these different color blocks here are all the different types of code that you can use to build your program. Whether it's an animation or a game or a website, it doesn't really matter. You will always use the same set of controls and tools. And this is the same for every programming language. We call it a syntax. Just like English or any other language has an alphabet, A, B, C, D, E, F, G, etc. This is the alphabet of programming. Every different type of code has its own alphabet, and so learning a programming code is basically the same as learning a new language. In the middle here, this is a blank screen. This is kind of like the canvas. Now, when an artist paints a picture, they need something to paint on. And this is what we are going to be painting on. We are programming artists, and we're going to be making art via code. And this is going to be our canvas here. So everything that you take from here will be built here. And lastly, on the right here where the cat is, this is our display window. This is what the program will look like when it is finished. So in the middle window here, this will all be disguised. You will not see this when the program is running. All you will see is this one here. If I go to the top right hand corner and maximize full screen control, this shows you what you will see. Okay, so first, in order to build a program, this screen needs a bit of background. All of the backgrounds in Scratch are found in the bottom right hand corner. They're called stages, and we click on this bottom right backdrop. Now we can either search for the backdrop if we know one, we can paint our own, we can ask the computer to select one randomly, or we can upload our own. If you have a good photograph or a drawing or something that you would like to put in the background yourself, then you would upload it as a file into the Scratch software. For now, we're just going to choose a basic backdrop. Scratch has many built in already, and you can see that they cover a lot of different environments, from the Arctic to beaches, bedrooms, schools, castles, anything you can imagine really. There's a lot of good backgrounds already here. So for this purpose, I'm going to pick Jurassic because I like dinosaurs. And here you see, this has changed the backdrop. So if I maximize the screen again, you can see the cat is now in a Jurassic environment. The cat is always loaded in as a default character. You will always see this when you open Scratch the first time. But you can choose your own characters. You do not need to use the cat if you do not wish to. I don't want to use the cat here. So what I'm going to do is click on the cat and close with an X. And I want to select a different character. In Scratch, all of the characters are called sprites. A sprite is a character that you can give some action to. Basically, we can attach some code from over here into a character, and this tells him what to do. Move his arms, move his legs, run around, jump, sing, dance, shout, play basketball. We need the code to tell the character what to do. So I'm going to choose a new sprite, and because I am in a Jurassic environment, I am going to choose dinosaurs. And my favorite dinosaur out of these dinosaurs is the T-Rex. So now you see I've got a Jurassic environment and I've got my T-Rex. Now at the moment it's not much of an animation, he's not really doing anything, he's just standing there. But we will see later on in the other tutorials that we can actually do quite a lot to make him very active. If we go to the top left hand corner above the code, we have these three toggles here, these three tabs. The first one is code, and this is currently selected, so it's showing me these different types of code here. The second one is costumes. Now as you can see, this has opened up a new window with the dinosaur, and basically these are the 4 different costumes that are currently inbuilt. They say the word costume, but what they kind of mean is different animations of the dinosaur. So if I click down and select the different ones, you can see the dinosaur is drawn in a slightly different style. So if you were to flick between these very quickly, just like a flick book when you do drawings, this would help animate the dinosaur and give him motion and make him look realistic instead of just moving back and forth without moving his arms or his legs or his mouth or anything. You can use this button down here to choose a new costume, or you can paint to edit any of the costumes that are already provided. Again, you can ask the computer to pick a costume by random, or you can upload your own costume. If you have a picture of a funny hat or something that you wanted to put on his head, you could upload it here and import it and use it in the Scratch software. Now here, all of this window here are where the edits to this costume are going to be made. So these are all the different tools that you have to be able to change this dinosaur. So for example, some of them are grayed out because they're not applicable to the thing that we're choosing. Right now I've got this tool selected and it's just the mouse. It allows me to select things, click on things, move things, make them bigger, whatever I want to do. If I need to change the positioning, I can take him apart, I can do whatever I want. There are also tools for colouring. You can change the palette by changing the brightness and the saturation levels, or skipping through the colours, or a combination of both. So for example, if I want him to be blue, but I do not want him to be this colour blue, then I can change the saturation level to make it less blue, or the brightness to make it more blue, brighter or darker, depending what colour shade you want to use. We also have a fill option. So the paint option works like a paintbrush. It will paint in a line, just kind of like this. The fill option colours in any shape that has already been predefined. So if I hover over here, I can colour its entire body in blue. The next one is a line object. This allows you to draw straight lines. As you can see here, this is very wobbly and it's not very accurate. This isn't going to look good in a program. But if you need to draw lines for something, this allows you to join 2 x coordinates together. You let go, and there you draw a line. If you make a mistake, then this one is an eraser, and you just erase it from your project, and it will erase here also. You can see that everything that I do here is happening here in real time. This is showing me what the changes will look like in my finished project. If you want to add text to your sprite, then this is where you go. The big T is the font, These are the different type styles of writing. So you pick one that you like, and you click somewhere and you type. As you can see, it appears up on the display window wherever I put it, and if I move it here, it moves here. Okay, the next one is sounds. This is where the sounds for the dinosaur are kept. So right now we can see that there's one called pop. This means that if I got the dinosaur to play a sound, to make a sound, it would be this pop sound. If I wanted them to make a different sound, then I would have to select one from the chosen parameters within Scratch. And again, we can search for one inside Scratch already, or you can record your own sound if you wanted to make a big roar noise or something. Or you can get the computer to choose one by random, and you can upload a sound that you've already created at some point before. Right now I'm going to choose a sound, and I'm going to choose one that sounds a bit like a dinosaur. These are all musical instruments. You can see that they all play. Let's look for one that we can use for our dinosaur. What kind of sounds does a dinosaur make? Maybe there's a roar. Let's give him a wolf howl. Because he looks like he's howling at the moon at the moment. And here you can make the sound faster or slower. You can add some effects like echo. Make him sound like a robot. Make it louder or softer. I think this sounds quite a lot like T-Rex screaming, so I'm going to keep it like that. That's pretty cool. Okay. Now, back to the code. All of the different types of code that we're going to use in our projects are going to be found along the left-hand side here. Do not worry too much about learning where everything is right from the beginning. I'm going to go give you a brief overview at the moment, but you will learn this very quickly once you start using Scratch properly, and once you repeatedly use the same programs over and over again and the same tools, you will become very used to learning where they all are. Okay. So the first one that we have is the big blue one, motion. And this is pretty self-explanatory. It essentially gives motion to your sprite, the dinosaur. So this tells us what kind of movements we want him to make. So if I wanted my dinosaur to move a certain number of steps, I would use this move 10 steps and place it here. And you can change this number to whatever you want, 100 steps, 200 steps, 300 steps, but you have to bear in mind that you are limited by this display. If you increase the number too much and you ask him to run all the way across the screen, then maybe he will run off the screen. But I can show you at some point in a different tutorial how to stop this from happening. Maybe you can make him turn around or avoid the edge of the screen. But this is very possible in Scratch. Just going to delete this. As we can see, we've also got turn by X amount of degrees, currently set to 15 by default, but we can make him turn around as many degrees as we want through a full 360 degree revolution, just like a circle. We have the Go To button, which is an open field. At the beginning, by default, it tells him to go to a random position. So if we were using this, the dinosaur would run to any random position that the computer selects. But we can also change this. We can get him to follow the mouse pointer, so he follows the mouse pointer around, or we can define other characteristics that go to a different sprite. If there were two dinosaurs, we'd get one to run across to the other, or to chase a ball, or to do many other different types of functions. Underneath this one we have the Go To X, and you can see here Go To X and a value, and Go To Y and a value. Now, I don't know if you've already been taught this in school, but in computer programming, in the same as mathematics, we refer to forwards and backwards and up and down, left and right, with X and Y values. So, if you imagine a graph, let's use the costume to draw this quickly. If you're going to draw a graph in mathematics, you will have a line going down and a line going across, and numbers along here, numbers along here, and then these are called the axes. We have two axes, up and down, left and right. Up and down is known as the y-axis, left and right is known as the x-axis. The very center here is known as x0, y0, because he's right at the beginning, right in the center of the axis. And it means that the first number here would be 1, the first number here would be minus 1, the first number here would be minus 1, the first number here would be 1. And the axes can be as big or small as you like, but this refers to where the position of the dinosaur is in relation to the screen here. So, if I take this out, if you want to delete something, you want to be more careful when you're using your eraser, there are some zoom buttons here, and you can zoom in and be a bit more accurate to make sure that you don't accidentally delete something and erase something that you want to keep. But we don't need this for now, so I'm just going to delete it. If it will let me. Oh, I can't delete it because it's text. The text we can't delete by this way, but we can go to the text, select the text, right click, and cut it out. And there's our text gone. Okay. So, if we go to the display screen here, we've got the dinosaur, and to know where he is standing in this picture, anywhere he could stand has a different X or Y value. If he was standing right in the center point of this picture, then the X value and the Y value would both be 0. But he is not. He is standing just to the left of the center, and he is not at the bottom of the picture, and he's not at the top. Underneath him here, we have the name of this sprite, dinosaur. So you can change this just by typing in the box here. Mr. Martin. Next to this, you see we have an x and a y value. The x value shows us where, in relation to this center point, he is standing, left or right. And the y value shows us where, in relation to the center point, he is standing up or down, north and south. So, we can see that the dinosaur's current coordinates are minus 51, x, and y is minus 46. And if I was to change the background, there is a background which shows you this x and y axes. Here we go, x and y grid. When I change it to this, you can see that right in the center here is x0, y0. Because x starts at 0 at the beginning, right in the center, if you move this way to the left or west, then you are moving in a minus value. So minus 1, minus 2, minus 3, minus 4. As you go further along this line, the minus gets bigger. Right, as you can see here, this screen the display has up to minus 240. So if I typed in to put the dinosaur at x minus 250, he would disappear. He would go right off the page and he would be over here somewhere and he would not be part of our animation. So this is important to bear in mind. And the same goes from x0 right across here. We can see that the screen goes all the way up to 240, and this is a plus value. The same for y. Y starts at 0 in the center, and then goes to plus 1, plus 2, plus 3, plus 4 as you go up, all the way up to y180. And the same coming down. Y, you see the y value here, the end point of the display is y minus 180. Okay, continuing on with the commands. So, we have lots of different movement type commands, and you will get used to these as you use them more and more. Very useful is to tell a sprite to go to a certain set of coordinates. Also, we can get them to glide for a certain amount of seconds to a certain position, either a random position or one we define. And we can also, here's a more defined one, where we glide 1 second to a precise location. You need both coordinates to get a precise location. The pointing direction shows us which way the sprite is going to face. And this operates on a 360-degree tangent. Just like a circle, he will move around in a circle and face a different way. And we can also see this down the bottom here underneath the sprite. And we can edit this value just to see. Now, he's currently facing right, facing this way. And we can see that it's a 90-degree angle facing this way. If I change him to 180 degrees, which is half of the circle, then you see he faces down, the same as half a circle. 240 degrees, and he faces a little bit further. 360 degrees, and he faces upwards. So the direction that he is facing is equal to a circle, and you can spin him all the way around the radius of a circle to choose which direction you want him to face. As you can see, there are more values here for movement to change x by a certain number and change the set x to a certain number. And this is what I was referring to earlier. There is a bit of code in the program which allows you, it says if on edge, bounce, and this means that if he gets to y 180 or x 240 or x minus 240 or y minus 180, if he gets to this point and he wants to keep going because your value is too high, then once he hits the edge of the display here, this little bit of code tells him not to go off the edge and to bounce back somewhere into the display screen. The next set of commands, the purple set, are looks. And again, this is pretty self-explanatory. This is all of the commands for how we want the dinosaur to look when he's on the screen. We can do many things with him. For example, change his costumes so that he switches between these different animations whilst he is running. And we can also add text to make it look like he is speaking or thinking. So you can say hello, you can say whatever you want. In here, this is an open field, and we can type whatever we want here. And that will show up on the screen, but right now it's not showing up, and I'll show you why at the end of this tutorial. Here are the switch costume buttons, and also to switch the backdrop. So, when something happens, we can design the program so that when a certain event happens, for example, if the dinosaur was to run over here, we could say that when he gets there, we want the background to change. Because we can save many different backgrounds, just like the costumes. We click here, you can see I've currently got 3 backdrops in operation in this project. And if we go up to the top left hand corner, we can see that now costumes has changed to backdrops. And here are the different backdrops that I've been using. A black one that we started with, the Jurassic one that I loaded, and the XY coordinates that I loaded. For now, we want the Jurassic backdrop because this looks the nicest. The next set of variables we have is the sound variables. Now, this is when we want the character to make any sounds or display some audio. And we can either use the sounds that are preloaded into Scratch, or we can create our own sounds and upload them. We can manipulate the sounds and edit them by changing the effects, by making it higher or lower, adding echoes, and we can also clear all of these sound effects. We can increase the volume or decrease the volume, and we can set whether the volume starts at maybe 100% or a little bit quieter. The next set of tools is events. Now these are very, very important tools. They're all very important tools, but these are particularly important because these tell you how something is going to happen. Now, the first one is the green flag when clicked, and we looked at this one when we were in the class. This tells us that when the green flag is clicked, I want the dinosaur to do something. And the green flag is up here. This is the go button. Right now, our animation is stopped. So, if I wanted him to move when clicked, I would choose motion. I would go to events. When the green flag is clicked, I want him to move 10 steps. So now, when I click the green flag, you can see he moves 10 steps every time I click the green flag. He only moves 10 steps at a time because that's all I've told him to do. If I tell him to move 100 steps, he will move 100 steps. Similarly, under the events, there's many different ways. We don't have to start our animation by using the green flag. We can also use it by saying when a certain key is pressed. So if the space key is pressed, I want my dinosaur to point in a different direction. So now I'm going to press the space bar. And you can see, because I haven't told him to not go off the side of the screen, he's moved 100 steps. If I ask him to move minus 100 steps, he will come back, because he's moving along the axes, west to east, left to right. If I wanted him to go right into the center of the screen, I would put 0 for X and 0 for Y. And when the green flag is clicked, he will go to the very, very center of the screen. And you can set as many commands as you wish within this different box, and you can edit them as much as you want. So I could change the space bar to an up and down arrow, right and left, or any of the different keys on your keyboard. A to Z and 1 to 9. Also in the events, we have things like when this sprite is clicked. So if I was to click on him, this would tell him to do something. When the sprite is clicked, go to X50, Y170. And when I click him, there he goes. If I click him again, he comes back. To delete these boxes, if you make a mistake, you can either separate them and drag them over to the screen here, and they will just let go and they will disappear. Or you can right click on them and delete them. If you right click on two boxes that are still stuck together, then you may be able to delete multiple boxes. It will ask you, it will tell you how many boxes that it's going to delete. We also have some different controls to allow the backdrop to switch. When the loudness increases to do something, when you receive a particular message. The broadcast ones here, these are how the different characters and the sprites talk to each other. So if I told the dinosaur to broadcast a message to a second dinosaur, then I would use this. And this will tell the second dinosaur to do something when this dinosaur tells him to. And we will look into this more detail in one of the tutorials for building an actual project. We've also got the control. These are the control of the actions. So we've got the motion telling him to do things and where to go, and this is telling him how to do that. So we can make him wait before performing an action. We can ask him to repeat the action a certain amount of times. We can ask him to repeat a certain action forever. We can ask him to do very different things also. If is a very powerful statement. So we can say, if the music is playing, then go to this part of the screen. We can also use if and else, which is very similar. If something is happening, then do this. Else means if this thing is not happening. So, if I am awake, then study. else sleep. If I am awake, I should study. If I am not awake, I should sleep. You will get very used to these. Don't worry if they're very complicated and difficult to understand at the moment. We are going to use all of these a lot in the class and in the tutorials, so you'll have no problem understanding the concepts when it comes to building your own projects. We have things telling our character to wait, telling him to repeat until a certain point, until something happens, control to stop him, and also some clone ones here. This is a little bit complex and maybe we will get around to using them. We can generate clones of different sprites. So if I wanted dinosaurs to be everywhere and I wanted them all to be the same dinosaur and act all the same, then I can make a clone of this dinosaur and they will all be instructed by the clone parameters. We also have some sensing tools. So, if, for example, the touching one, if the dinosaur was touching the mouse pointer, if the mouse pointer was here, and the dinosaur decided to move along the x-axis towards the mouse pointer, then I could tell the program to make something happen. In the drop-down menu, at the moment we don't really have anything for him to interact with, so at the moment he can only touch the mouse pointer or the edge of the screen. So I could say to him here also, if he's touching the edge of the screen, to move back to a certain direction so he doesn't go off the screen. We can get him to ask things like what's his name and wait, and to answer, and this basically just picks up on any inputs that you want to put into the program. So if you want something to happen when you press the number 1, you would use these particular functions, or if you wanted something to happen when you move the mouse down, or if there's a timer that runs out. This is where you'll find all of these different things. The green ones are called operators, and these are basically how we use mathematics in programming in order to control what goes on in the program. And these are very, very, very powerful, and we will see how later we can use specific examples of something plus something, something minus something, something multiplied by something, a value divided by a value, or we can get the computer to pick random values, which can also be very useful for making natural movements. We also have these ones here, which are if something is more than something else, if something is less than something else, or if something is equal to something else. We have and, we have or, we have not, and we have the ability to join things together. As I said, don't worry too much about this at this stage. We will be using these, and I will explain to you in more detail how they can be used to their strengths. The last set of blocks here that we have on the screen, the orange ones, called my variables. Now basically what this means is that you can assign value to things in your program, and you can create your own values, and these values are called variables. So, for example, if I wanted the dinosaur to jump up and down, jumping up and down requires gravity. Now, this is a computer program, it's not the real world, so I cannot get gravity to happen naturally. If the sprite jumps, this is not real life, it's just on a computer screen. I need to make gravity. Gravity is controlled by something called velocity. Velocity is the speed at which something falls, or rises, or moves. And we can create gravity by using velocity. And so how I would do this is that I would make a variable, and I would name my variable velocity. I can choose to make this variable applicable to all of the sprites that I have. So if I have 10 dinosaurs, then I can make this affect all 10 dinosaurs, or I can make it just affect this one dinosaur, which I'm going to do here for this sprite only. And here you can see that the velocity of Mr. Martin the dinosaur is currently 0 because he is not moving anywhere. There is no speed. As something falls in gravity, the velocity increases. But this is something technical and scientific. Maybe it's outside of what you've learned in physics so far, but it's not too much to worry about. You will understand when you're actually using it. Finally, we've got mybox. This is something you will explore later on, and you can essentially it allows you to create your own blocks, just like these ones. So if there's something that you want to do that these blocks do not do, or you want to create a block that is a combination of lots of these different blocks to save making a big combination every time, then we can do this also. Finally, we've got the button down here called Add Extension. Now what this does is basically there are a lot of other controls like these tools that are already included in Scratch. They're not put on the sidebar here by default because many programs do not need to use them. But we can use them if we want. So you can see that there's music ones, there's pen ones, there's video sensing, there's text to speech, there's translation, there's ones to make things into different keys, connecting projects with the world through networks, and some Lego plugins also. These three at the bottom, you can see these require Bluetooth because they need your device, your computer, to communicate with a different device. And if we choose the pen, we can see that the pen has appeared here as a different tool, and this has all of its own different tools also. So we can set the pen color to a different color, we can change the color by a different value, we can change the pen size, we can put the pen down and put the pen up, which is very important because we need to tell a computer program to do everything. So if I want to write on a piece of paper, how would I do this in computer programming if I wanted to tell my arm how to write? First of all, I would need to tell my hand to pick up the pen. Then I would need to tell my hand to move towards the paper. Then I would need to tell my hand to put the pen down on the paper so the ink is touching the paper. Then I would need to tell my hand to move around until I have written or drawn what I would like to write or draw. And when I am finished, I would need to pick the pen up. This is a very good example of how we build everything in computer programming. Everything works like this. Nothing will happen in a computer program unless we tell it to. So, it is usually very important, just like when writing a story, that we plan out what we want to happen in advance, and we try to think of all the different things that we need to tell the computer to do in order to make something happen. And just like my example with getting my hand to draw a pen a moment ago, this is how we think about it. What do I need to do? First, what's the first problem? The first problem is my hand needs to have the pen in its hand. So I need to pick up the pen. Then when I have the pen in my hand, I need to be touching the paper. Then I need to move my hand to make the drawing or the words. And when I'm finished, I need to remove my hand from the paper so that the ink stops spreading. Okay, I think that is enough for the first tutorial. I would like you to just play around a little bit with these different tools and the different backdrops and get used to loading sprites in and out of your display, and get used to the X and Y coordinates. Play around with these and have a look at how this affects the movement and positioning of your character. The next tutorial is going to be the first tutorial in actually putting some meaningful animation into these characters here. And the next tutorial after that will be our first project that we are going to build. So, I hope you've enjoyed this tutorial. I'm really looking forward to seeing all of the different projects that you guys are going to make. It's going to be very exciting. I think you are going to learn a lot. I think I will learn a lot. And hopefully we can make some really cool animations to show our parents in the future. So, that's it for today. Thank you for listening, and good luck having fun. Have fun with Scratch.